All right, section 3.3, I'm going to split up into two parts. First of all, we have a new postulate. Postulate 16, corresponding angles converse. So if two lines are cut by a transversal, so the corresponding angles are congruent, then the lines are parallel. So this converse means it's like we're using the postulate to prove lines are, it's like we're using corresponding angles to prove lines are parallel. So to draw you a picture in red, I always use P and Q, J and K with our transversal T. So if angle 2 and angle 6 are congruent, so we have it 2, goodness. If angle 2 is congruent to angle 6, then J is parallel to K. Okay? Let's do an example. Find the value of X that makes M parallel to N. So if we had, if this angle and this angle are equal because they are corresponding, so if they are equal, then those lines are parallel. So let's make sure they are equal by setting them equal to each other. X equals 20. So if X equals 20, then M is parallel to N. You try. Is there enough information in the diagram to conclude that M is perpendicular to N? Explain. Go ahead and try this on your own and then come back for the answer. Okay, I needed to prove that this angle and this angle are congruent. Okay, because those are the corresponding angles. Once we know they're congruent, then we know the lines are parallel. So I did 180 minus 105 and got 75 degrees. 75 degrees equals 75 degrees. So yes, they're parallel because of postulate 16. You try the next one. Explain why postulate 16 is the converse of postulate 15. Because postulate 16 switches the hypothesis and conclusion of postulate 15. All right, we have some new theorems. Theorem 3.4, alternate interior angles converse. If two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So let's get our drawing. I have angle 4 and angle 5. So those little arcs say that angle 4 is congruent to angle 5. So we know that J is parallel to K. Theorem 3.5, alternate exterior angles converse. If two lines are cut by a transversal, so their alternate exterior angles are congruent. 1 is congruent to 8. Then the lines are parallel. It's J, K. Theorem 3.6, consecutive interior angles converse. J, K, transversal, consecutive interior angles. Okay, we have 3 and 5. If two lines are cut by a transversal, so the consecutive interior angles are supplementary, then the lines are parallel. So angle 3 and angle 5 are supplementary. So if 3 and 5 are supplementary, then J is parallel to K. Remember, that means that angle 3 plus angle 5 has to equal 180 degrees. Let's try an example. How can you tell whether the sides of the pattern are parallel in the photo of a diamond back snake? Okay, so I have, how can you tell whether they are parallel? Let's use blue. So I have these two lines, and I know they're congruent by the picture. Okay, so if you know that those two angles are congruent, so lines are parallel. Makes sense? Okay, you try. Can you prove lines A and B are parallel? Explain why or why not. Okay, that one is Theorem 3.5, the alternate exterior angles converse. Because the alternate exterior angles, that was messy. The alternate exterior angles are congruent, and therefore A is parallel to B. Okay, you try this one. Can you prove that lines A and B are parallel? Explain why or why not. The postulate 16, the corresponding angles converse, proves this one. Because our corresponding angles are congruent, A is parallel to B. Last one, go ahead and try it. Can you prove that lines A and B are parallel? Explain why or why not. Nope. Angle 1 would have to be congruent to angle 2 for A to be parallel to B, and these aren't necessarily congruent. Okay? We're going to start this one tomorrow, so see you in class.